Hello everyone, welcome to my channel. Today I will tell you a story to help you understand a new paper. I recommend this paper, Active Learning of DNNs Networks, while gradient-free cutting plans. This is a new ICML paper in 2025, and I will use a story to tell you the main idea and briefly explain how to implement it. So you have the idea how to better understand it if you are interested, and then you can get the details of the paper. So let's get started. Why we talk this paper? Because I'm quite interested in the trustworthy AI. When we are so excited by the AI model like ChatGPT, DeepSeek, all these models can give you some answers, but the current challenge is that sometimes it may give you the very surprising, great answer, but in some cases, it gives you very ridiculous answers. So you know it has some mistakes. So in some areas, we don't like this kind of mistakes. We want to trust the model and guarantee the results is always reliable, correct, particularly in the self-driving, power grids, robotics. We want to make sure the model is reliable and the result is valid. So we like the model that is both valid and reliable. How to do that? This paper proposes a new training algorithm that can guarantee the reliability, while the traditional training algorithms like the stochastic gradient descent or other gradient descent-based methods cannot provide the guarantee. Have the deeper understanding of how it does. Before getting to the details, what is the main idea? So let's say you have a giant block of clay, like here, and you know there is a golden statue inside this clay, and you want to find it. The idea is to cut. So there are 3 steps based on the methods proposed by this by the paper. So you use a stick and pull to one part of this clay and ask the proposed method, does this part of the clay include the golden statue? And if it says no, you can use a knife to cut out all this part of clay that may produce a similar mistakes. Similarly, you pull another part, ask, and cut until eventually the useless clay is cut off and the golden statue remains. That's it. So instead of using the gradient-based methods, doing the downhilling descent, we propose to cut off the parts that does not work. And eventually you have a perfect model that can help you to produce reliable and accurate results. Do you like this idea? Okay, let's talk about how to implement it briefly. There are 6 steps to implement it. First is to enumerate activation patterns. You may wonder what is pattern, what is active function, why we need to enumerate it. I encourage you to read the details of this paper, but generally the pattern means the on or off states of the value function. Value function is active function, and if you determine the on and off states of value function, you can get the you can transform the neural networks into a linear model. But there are different kinds of patterns, and to produce the complete, accurate output, you need the finite number of patterns, and their linear combination can give you the correct prediction. So the first step is to enumerate all possible patterns, and this step can transform the non-convex neural networks into a convex neural networks. That is the key step, how they can provide the guarantee of the accuracy of the output. After you enumerate these patterns, you transform the neural network training into a linear program. So the second step is that we want to learn the parameters of the neural networks by solving a linear program. Clean, you need to cut up. How to cut? The next step is to find a center. Center represents the parameters that always satisfy all the requirements, all the constraints. So you need to find a center, and the final center is the parameters of neural networks. There are different ways to define the center, so you can check the details, but the main idea is that center is data that is far away from all other constraints, and it is guaranteed to be satisfactory. The next step is to query all the unlabeled samples. When you compute this center, you need a lot of unlabeled data, and you can solve this, and then you can use the one constraint in this linear program. This constraint can measure the margin of each unlabeled data to the constraints of neural networks. And according to the this margin, you can order different unlabeled data so that you have a query, and the label that has a minimum margin is treated as the weakest point. So you can use this point to define the cut. So that means you find at least one bad point, and you know that all data for outside this cut are useless. So you want to cut them off. So after you find this weakest point, the next step is to use this data to define a cut, and then use this cut, go back to the linear program you define in the step B, and solve it. After you solve this cut constrained linear program, you can find the new parameters, and in these parameters you can define a new center. So in this way you can repeat step C to step E, and until there's no improvement or you reach the largest iteration number. After you find the optimal center, which is parameters of the neural networks, and it's done. This training neural networks becomes this iterative cutting plan problem. After you solve it, you have the theoretical guarantee that the parameters are optimal, and you can try other tools to verify the outputs of the neural networks. And they did some experiment to compare the proposed method, the red one, and other linear model, and they show that they get better accuracy, can say in different. They compare the methods with linear model, with random sampling, with gradient descent, and they get much better accuracy when they have more data. Okay, let's wrap up what we have learned today. So this paper proposes a new algorithm that does not use the gradient descent, but provides the optimality guaranteed parameters. And they only use a small number of label data samples that is particularly useful for the areas that have very insufficient number of labels, like in the medicine area or robotics or progress. And I believe the paper formulate a new template or new way for the trustworthy deep learning training. So if you like it, you can try it, and their code is in the GitHub. Thanks for your attention. If you like my story and want to share your experience of learning AI papers, please subscribe me, and I will update papers as soon as possible. And also join our Slack group. Thank you.